Hello, friends. How are you all? I'm sure you all are doing good, doing well. Preparations on track. All right. So now let us start the new series in our con preparation, that is algebra. I'm sure when I say algebra, what all comes to your mind? Yes, world of unknowns. X, Y, Z, variables, constants, graphs, functions, equations, inequations, unknowns, so many things, right? Ultimately, this is a very smart topic and nice topic also. Basically, if something is to be found out, yeah, so you have been given clues to find that. So you have to use those clues smartly. Okay, you have to use those clues smartly and come up with the final solution. So how do you plan using those clues and the information what you have? You mix and match, create some equations, expressions, inequations, all those things. Let's explore. Yeah. So in algebra, what are the topics which I wish to cover? First will be all about linear equations and all those things. All about linear, then all about quadratic, then inequations. Yes. Then relations and functions. Then some special function, that is the modulus function. Then maxima, minima. All right, friends. Binomial theorem. After that, progressions, that is your sequence and series, AP, GP, and all those things. And finally, coordinate geometry. Basically, whatever bare minimum you should know in all these topics, that we'll be covering. Okay, so let us start with linear first today. Okay, the moment I say, see, first of all, what is equation? When you have some relation between x and y, that is unknowns, right? Unknowns, generally we use the terms as x, y, z, and all those things. Constants means a, b, c, k, like that. That is our convention till now. So if you have some relation between the constants and unknown, and then you have equal to some other value, then it is equation. Just the relation between x and y, something like this. This is expression. Now, if I write this equal to some number, but this is equation. Yeah, and if I write like this, less than, more than something, that is inequation. That's it. Highest power of the variable which you are using is called as degree. So if the highest power is 1, it is linear, simply because if you plot the graph of this, you are going to get a straight line. All right. So what is the linear equation? How does it look like? See this example, 2x plus 3y equal to 6. Did you see x and y variables? Highest power is 1, right? Perfect. So if I plot this on the graph, you know very well, it will give me a straight line, hence the name linear. What is the standard form? Means which can take care of all the varieties. Generally, ax plus by plus c equal to 0. This is how the linear equation looks like. Generally, we can represent it on a general platform. Ax plus by plus c equal to 0. Did you see x and y again? Highest power is 1. So degree is 1. All right. Types. First, here 3x plus 11 equal to 23. I hope you could see only one variable. Yes, only one variable. Correct. Okay. Then two variables, isn't it? Two variables means check x and y. Two variables, ultimately highest power is 1, linear. But two variables, two unknowns. It can be three variables also, x, y, and z. but one thing will not change. What? Highest power will be 1. Okay, getting it? So what did we cover till now? What is the linear equation? Highest power 1. Yeah, it gives us a straight line, correct? Hence the name linear. Standard form is this: ax plus by plus c equals 0. Again, you can see x and y highest power is 1. Then we saw types: 1 variable, 2 variables x and y, 3 variables x, y, and z. But one thing doesn't change. What? Highest power is 1, isn't it? All right, let's go ahead. Now, when we come across simultaneous equation, before that, let me tell you one more thing. In this case only, you are going to get a unique answer, isn't it, friends? You're going to get a unique answer. Unique answer means there's a unique value of the variables x equal to 4, which will satisfy this equation. Simply because there was only one equation and one unknown. Hence, we could solve that unknown. We could find that unknown. In this case, if you see, friends, there are two unknowns and only one equation. Two unknowns and one equation. Don't you feel there'll be so many values of x and y here which you can adjust, which will give us ultimately 21? Just to name a few. If x is 7, y is 0. If x is 0, y is 3, and so on. You can have so many combinations of x and y, isn't it? So there'll be infinite solutions. Same with this. When number of unknowns are more than the number of equations, you'll always end up getting infinite solutions, isn't it? Ultimately, what are these? They are nothing but the coordinates of the points. Yeah, 7, 0, 0, 3. If you join, you'll get the straight line. And a straight line has infinite points, isn't it? That is the infinite values of x and y will satisfy this. That is what you should understand, the logical connection. Okay. This also is a straight line only, friends. Later on, you'll understand x equal to 4 means it's a line parallel to x axis passing through 4, 0, vertical line. Every point on this x is 4. All there are infinite points, but sub में value तो एक ही है ना, x equal to 4. Hence, I can say there is a unique answer that way. Okay. Now, let's explore simultaneous equation. Simultaneous equation means there will be two equations which you are trying to solve simultaneously. And one more thing, the answer which you get at the end, answer of x and y, if I'm talking about two variables, that will satisfy both the equations simultaneously. And graphically, the meaning of that will also be there. I will tell you that. Okay, just hold on. For example, this is as of now one equation, two unknowns. You can't solve. Can't solve means there will be infinite answers of x and y. If I support it with one more equation, yeah, and now if I try and solve both of them together, and there'll be methods of solving. Ultimately, what is the method of solving? The main crux is you have to solve in such a way that you eliminate one variable so that you get the answer of the second variable. Substitute that value in the first variable, any one of the equations, and you'll get that other variable answer. That is the plan basically. So here it is very easy to eliminate because coefficient of x is same, 5x and 5x. I'll subtract. So if I subtract 9y minus 7y, I'll get 2y is equal to 20 minus 10. That is 2y is equal to 10. So y is 5. This is what I was talking about. So y is 5. Substitute in any one of them, you will get the value of x. Correct. Now, suppose here I substitute y as 5. This is 35. So 5x plus 35 is equal to 10. So 5x is equal to 10 minus 35. So minus 25 divided by 5. So x is minus 5. Ultimately, what does this represent? If you see, there are two straight lines now. Yeah, two straight lines. They will be intersecting somewhere if they are not parallel, if they are not overlapping. Why am I saying this? Hold on, stay tuned. You'll come to know. So as of now, I know that these two lines are intersecting. So if they intersect, they'll always intersect at one point, isn't it? Yeah, so the coordinates of that is minus 5, 5. So this is nothing but the coordinates of the point of intersection. At least this much minimum understanding should be there. Okay, all right. Next, see this now. No coefficients are same, so you try to make them same. How? By sortable multiplication. So if I multiply first equation by 5, second equation by 3, so what will happen? Can you visualize? This will become 15y, this will also become minus 15y. So then I can add them up so that y gets eliminated. After solving, I'll get x, resubstitute x in any one of these two equations, get y. Get it? So first equation, second equation, after multiplication by 5 and 3 respectively, add them up. So 15y gets cancelled, 44x is 44, x is 1. Substitute in, suppose first one, 7 into 1, 7 plus 3y is equal to 13. So 3y is equal to 13 minus 7. So 3y is equal to 6. So y will be 2. Correct, na? Again, what is this? Yes, point of intersection 1, 2. Correct. So there were two equations, two unknowns. Hence, there was a scope of a unique answer, unique solution. Means there'll be a unique point which will be present on both of them. That is nothing but the point of intersection. So this entire algebra should understand that whenever you want to find point of intersection of two lines or two curves, solve them simultaneously. Okay, solve them simultaneously. All right. Now one more interesting concept. Sometime back I was telling you, if the lines are not parallel, if they are not overlapping, that is if they are intersecting at one point only, then we have a unique solution. So how do I know whether the lines are parallel or overlapping or intersecting? And if you see carefully, these are the only three cases, isn't it? Okay. Now check this. As of now, it might look that there are two equations and two unknowns. So of course, we will start solving. But hold on. If you solve this carefully, in the first equation, suppose you multiply by 3, second one multiply by 2, solve, you will get 0 is equal to 0 at the end. X and y and constant, everything will get cancelled. Yes, you can check. Okay. 0 equal to 0. Mathematically, so this is a true situation, right? Correct situation. 0 equal to 0. But variables got cancelled means this is always true kind of situation, means there will be infinite values of x and y first of all. And one more simple logic, actually I had derived the second equation by multiplying by 1.5 in the first equation. In short, it is like I have written one equation only two times. So ultimately both these lines are one and the same lines. So logically, if you try and plot them, they will be like overlapping lines. If this is the first line, you plot the second line, it'll be giving the same line. It's like both the lines are coincident, overlapping each other. So don't you feel every point will be common between them, logically speaking? And a line has infinite points. Hence, this particular situation will have infinite solutions because it is as good as only one line. So one line has infinite points. There will be infinite values of x and y which will satisfy this. Now, how do we identify in general? Here I told you that I have multiplied the first equation by 1.5. You can check this out. Ratio of the coefficient of x. There it is 6, here it is 9. All right. So 6 upon 9. Yeah. Take the ratio of the coefficients of y, 9 and 13.5. And if you check carefully, both the ratios are exactly same. Both are 2 by 3. And finally, they will be equal to the ratio of the constant terms. Whenever this situation happens, then only we say that it's only one equation written twice. So ultimately one equation and two unknowns. So infinite solutions. Okay. So in general case, I am writing the formula as A1 upon E2 is equal to B1 upon B2 is equal to C1 upon C2. All right. Cool. Yeah. Understood? Infinite solutions. This case, generally you are not exposed to these kind of situations in childhood, that is up to 10. We are always given two equations which used to be solved and we used to get one answer only. But now be alert, be aware that there are two more situations. This is what first one. Let me show you the next one. Okay. Again, two equations, two unknowns. You might feel, obviously you should feel that they can be solved and you will get the value of x and y. But once you start solving here, friends, yeah, once you start solving here, suppose first equation I multiply by 5. So 20x plus 35y is equal to 50, isn't it? Second equation multiply by 2. Because I tried to use that logic. I'm trying to make the coefficient of x same. 35y is equal to 60. Oh my god. I hope you must have realized. Subtract. Everything got cancelled. 0 is equal to minus 10. 0 is equal to minus 10. Is it true? Of course not. This is an impossible situation. In earlier case, we got 0 equal to 0. At least that was a true situation, right? But 0 equal to minus 10, impossible. It simply means there is no value of x and y which can satisfy both of these equations simultaneously. Mean there is no solution. Graphically, if you see, first line and the second line, they both are parallel lines. And later on, when we do coordinate geometry, you'll understand that simply because their slopes are same, that is why they are parallel. Whenever the slopes of two lines are same, they are parallel. And parallel means they will never meet, isn't it? Yes. How will you know it in general? So ratio of the coefficient, we have to simply check the ratios. Ratio of the coefficient of x, ratio of coefficient of y. Both of them will match here. Both of them are 2 by 5 if you try and check. Yeah. But the ratio of the constant terms is 10 by 30, that is 1 by 3. It is not matching with the other ratios. If this is the situation, then there is no solution. So in general, this is how you'll write, right? Okay. So lines are parallel, they will never meet. So no solution. Such kind of equations in algebra are also called as inconsistent equations. So inconsistent means no solution. Yeah. Of course, if the lines are parallel, there won't be any point which will be present on both of them which will satisfy them, isn't it? Correct? Okay. I hope you understood these two varieties, these two situations. Cool. Now, next example. As we have already discussed, there are only three situations. Either the lines will be overlapping, coincident, so infinite solutions, or the lines will be parallel, two different lines and parallel lines. So no solution. They will never meet. And what is the third case then? Bacha hi kya hai? They will have to intersect. They are not parallel, not overlapping. So they will intersect. And if they intersect, they will intersect at one point only. This is that situation. And this is what we were exposed to since childhood. Okay, friends? And one simple identification point. The ratio of the coefficient of x will not match with the ratio of the coefficient of y. This is the bare minimum simple condition to understand that the two equations are different, two lines are different. They are independent equations. So lines will be intersecting lines and we will be getting a unique answer. So in general, a1 upon a2 should not be equal to b1 upon b2. That is the ratio of coefficient of x should not be equal to ratio of coefficient of y. So if you solve them now, they will intersect at some point. So obviously you will get the answer here. इन दोनों को सॉल्व करके x और y का एक यूनिक आंसर आएगा और वो क्या होगा कोऑर्डिनेट ऑफ दिस पॉइंट राइट okay consistent equation. So whenever there is a solution now we call them as consistent equations. Inconsistent क्या था no solution तो उसका opposite क्या होगा consistent equations means having at least one solution, whether one solution, two solution, infinite solutions, the equations will be called as consistent. No solution means inconsistent. Okay, all right, understood till here friends? All the three cases, keep revising. All right, good one, thank you. Let's go ahead. Now next topic, next concept to be understood friends is a very nice logical topic. This will help you in a lot of tricky situations wherein you have to explore a lot of possibilities. How many possible solutions are there, how many integral solutions are there, something like that. So the number of integral solutions. First of all, integral means yes, numbers without decimals. Three magical words, remember them. Integers means numbers without decimals. They may be positive, negative, zero, anything, but free of decimal. Okay, let's take this example. First of all, this is a linear equation. Equal to sign is there, variables have highest power as 1, so it will be nothing but the graph of a straight line. Okay, all right, again one equation, two unknowns, so infinite solutions. ये सब तो clear है right? Now this basic is clear, very good. Okay, all right, there are infinite solutions I know, but I'm specifically targeting integral solutions first of all. तो सारे decimal वाले चलेंगे. In that also friends, I am just targeting as of now, suppose non-negative ones. Non-negative means whole numbers, non-negative integers, that is zero or positive integers, that is zero or natural numbers. Let me first do it manually without any logic, without any background. So if I put x as 0, so 3y is equal to 100, so y is 100 by 3. But 100 by 3 is not divisible. 100 is not divisible by 3, so it will be a decimal number. So it is not integer, right? Okay, let's move ahead. Let's put x as 1, suppose. So 3y will be 100 minus 2, so 98. So y is 98 by 3, again, not an integer. Let me put x as 2. So 2 to the 4, 100 minus 4, 96. 3x is 96, x is 96 by 3, 32. This is integer. So this is my first integral solution. That is when x is 2, y is 32. Yeah. When I proceed further, x को 3 put किया, फिर से y decimal में आया, rejected. x को 4 put किया, फिर से y decimal में आया, not happening. Then x को 5 put किया, I got y is 90 by 3, that is 30. Next integral solution. Now just hold on. Let's understand that shortcut, that common sense, that pattern. Did you see? After 2, I got the next solution only at 5, not in between. So it increases by 3. And after 32, next value was 30, which was 2 less. Check the logic here. At the end, if I'm just stopping at non-negative answer, so when x is 50, at that time y is 0, right? 15 to 200 plus 0 hona chahiye, so y will be 0. So did you see this logic? X changed by 3 means x changed by a value which was coefficient of y, isn't it? And y changed by a value which was coefficient of x. And there was plus sign in between. So we saw opposite behavior. Opposite behavior means when x increased, y decreased. I'll tell you the reason for this also. There's a nice logic behind this. That is nothing but slope. Okay, slope. So if you just count number of positive integral solutions, I'm sure you must have got it. Right from 2 up to 32, to 2 ones are to 2 16s are. So there are 16 solutions. And if you count non-negative means now you'll include that last one also, that is 0 wala solution. So one more solution. So 17 such solutions are there which are all non-negative integral. Got it? So here there was a plus sign in between. Then we saw this pattern. Let's explore one more case, of course, when there is minus sign in between, isn't it? Check this again. Now no need to explore like the way we did in the beginning for the previous situation. So now we already know some basic shortcut that x will change by 3, y will change by 2. Yeah. You just have to find the first solution manually. You just have to find the first solution manually. So when I put y as 0, 2x is 100. Wow. At y equal to 0 only I got. Generally, I start putting the values of the variables which has higher coefficient, because then I will be able to track the solutions faster. 0 put किया उस पे ही मिल गया, नहीं मिलता तो 1 put करता, 2 put करता, 3 put करता, कहीं तो जल्दी से मिलता था. So this is my first solution, I am very sure. Now I know the pattern. X will change by 3, y will change by 2. But logically if you try and satisfy, both of them increased. यहाँ पे एक कम और एक बढ़ नहीं रहा है, अपोजिट बिहेवियर नहीं, यहाँ पे सेम बिहेवियर, सेम डायरेक्शन. Either both are increasing, you can say, or you can say both are decreasing. If you see reverse, 53 से 50 हो गया, 2 से 0 हो गया. So both of them will change in the same direction. Yeah. Next solution, now you know, you don't have to check manually now. क्या? X का next answer क्या आएगा? +3, 56, और Y +2, तो 4, and so on. अब यहाँ पे तो कोई end नहीं ना, कोई restriction नहीं है, तो both of them are integers, they can continue. If you keep adding 3 and 2, 3 and 2, तो integer में integer add करूँगा तो next integer ही मिलेगा ना. And there is no end. In this case, there will be infinite solutions. In the earlier one, there was upward behavior. तो एक बढ़ रहा था तो दूसरा कम हो रहा था. That is why we saw that opposite behavior. But यहाँ पे same direction है, तो कोई end ही नहीं है. So in the question, they'll have to give us some condition that x should be less than or equal to 1000. Then we can count it. Otherwise, infinite solution. Yeah. I hope you understood till here. Okay. Cool. Now to understand the logic behind these two situations, let's first understand actually till now we are taking these two words very casually, but now be very careful in algebra when we are talking very seriously. Roots and solutions are two different things. Let's first understand that. For that, I'm taking the example of quadratic. I'm sure itna to sabko pata hi hai what is quadratic. Some basic knowledge is already there thanks to 9th and 10th standards. So if you factorize this at the end, this is how you get, right? Y is equal to x minus 2 into x minus 3. Let me first explore the way we used to plot graphs in schools. take some values of x, accordingly you'll get values of y, and then join those points, then you get that shape. ठीक है, x को 0 लिया, so do you understand -2 into -3 will remain means 6 आएगा, या तो यहीं पे पुट कर दो x equal to 0 तो y 6, x को 1 लिया तो y 2 आएगा, x को 2 लिया तो y 0 आएगा, x को 3 लिया तो भी y 0 आएगा ऑब्वियसली, x को 4 लिया तो y 2 आएगा. You can check here or from here, both are same thing. This is a normal form and this is a factorized version, right? Factorized version means product or division वाला version. For example, 10 को अगर आप 8 plus 2 लिखते हो, so this is not factorized version. 8 is not a factor of 10. But if you write this as 2 into 5, this is called as factorized version, wherein you are using factors of 10, okay? Similarly, if you take x as 5, y is 6. Now, if you just plot these points, this is how the graph will look like. What a shape, na? Oh, London Bridge भी ऐसे ही है ना? And when you throw a stone, उसका path notice करो, ऐसा जाता है फिर ऐसा गिरता है. This is called as parabola. क्या बोला? Parabola. This shape, this curve is called as parabola. Now check this. All these values of x are called as solutions because at every x I was getting some y, so they are all solutions. But specifically when y was 0, those particular values of x are called as roots. This is the real meaning of roots. Those values of x for which y is 0, they are only called as roots, isn't it? And graphically, what does that mean? Yeah, when y is 0, where y is 0? On the entire graph, what do you feel? Where is y 0? Of course, on entire x-axis, every point has y coordinate 0, isn't it? Yes. So these are the roots. So this is your 2, 0 and this point is 3, 0. All right. Cool. Got it? So those values of x for which y is 0, they are called as roots. That is why we equate this to 0 and solve, na friends? Means हम लोग y को 0 ले रहे हैं. So we are trying to find that x for which answer of y will be 0. Final output of y will be 0. So after solving out these values, means we can say at these values of x, y is 0. So these are the two roots. Now be comfortable. Roots का एक दूसरा word भी है. Based on this nature, they are also called as zeros, right? Spelling check कर लेना, पता नहीं Z is ROS है कि Z ROE है, पता नहीं, sorry. So but zeros. So zeros of any polynomial, zeros of any equation means those values of x for which y is 0, the output is 0. So we are specifically evaluating that because we are interested in finding out कि जो भी कर्व बन रहा है वो x एक्सिस को कट कर रहा है या नहीं कर रहा है, और कट कर रहा है तो कहाँ पे कर रहा है. Okay, all right. Now let's understand this. Already we know x will change by 5, y will change by 3. देख रहे हो, एंड प्लस साइन है तो अपोजिट बिहेवियर है. करेक्ट. x was increasing by 5, y was decreasing by 3. या पीछे जाओगे तो भी वही नेचर है. हम सोच रहे थे ना क्यों, why. लेट्स सी. इसका जो स्लोप है, अगर आपको याद हो थोड़ा था, we can write this equation, rewrite this equation in the form of y equal to mx plus c. So can you see this coefficient of x, that is -3/5, that is slope. Negative है slope. Slope negative मतलब decreasing line. And how do you analyze a decreasing line? The more, if you're moving from left to right मतलब ऐसे जा रहे हो तो x तो बढ़ रहा है, number line, come on. But graph नीचे आ रहा है मतलब y नीचे आ रहा है. So x is increasing but y is decreasing. So opposite behavior हुआ कि नहीं? Correct ना? Yeah. When x is -3, y was 4. अब यहां से आप 5 यूनिट आगे जाओ राइट में तो y अपने आप 2 यूनिट कम हो जाएगा, सॉरी 3 यूनिट कम हो जाएगा. करेक्ट. सो स्लोप वाज चेंज इन y अपॉन चेंज इन x, इसको बोलते हैं स्लोप. इसंट इट? नोटेशन है m. सो हियर स्लोप वाज -3/5. सो y विल चेंज इन द मल्टीपल्स ऑफ 3, x विल चेंज इन द मल्टीपल्स ऑफ 5. ये रेशियो का लॉजिक है, इसंट इट? एंड माइनस मतलब अपोजिट बिहेवियर. दिस शुड बी कन्विंसिंग नाउ. और आप 5 यूनिट आगे जाओगे मतलब 2 से 7 पे जाओगे तो y 3 यूनिट से गिर जाएगा, तो 1 - 3 -2. देखा? दिस इज द लॉजिक. सो यू आर जस्ट ट्रैकिंग दीज पॉइंट्स ऑन द लाइन which had integral coordinates, isn't it? Cool. माइनस वाला भी देख लेते हैं, लॉजिक वी ऑलरेडी नो, x will change by 5, y will change by 3, but now both of them are increasing, isn't it? और ऊपर जा रहा तो मतलब both of them are decreasing, आप कोई भी लॉजिक से देख सकते हो. Again rewrite this as y equal to mx plus c, so m means 3 by 4, 3 by 5. अब स्लोप 3 by 5 है, मतलब चेंज इन y अपॉन चेंज इन x, वो डेल्टा है, चेंज के लिए हम लोग डेल्टा लिखते हैं, so 3 by 5 पॉजिटिव स्लोप पे, तो इंक्रीजिंग लाइन, जैसे जैसे x बढ़ेगा y भी बढ़ेगा. मैं लेफ्ट टू राइट जा रहा हूँ तो मैं ग्राफ ऊपर जाता हुआ देख रहा हूँ, मतलब y भी बढ़ रहा है, so when x is increasing y is also increasing. ठीक है, you can just take any one point to begin with, x is -2, y is -3. सॉरी मैं उल्टा बोला ना, x is -3, y is -2, ये वाला पॉइंट. So now if you move to the right side by 5 units, y will increase by 3 units. तो -3 से 5 राइट में जाओ, या तो y will automatically increase by 3. That is the setting, that is the change in x and y का पैटर्न. तो -3 में 5 ऐड किया तो 2 आया, और -2 में 3 ऐड किया तो 1 पे चला गया. फिर से 2 से 5 यूनिट्स आगे जाओगे तो 7 मिलेगा x का, और 1 में ऑटोमेटिकली 3 ऐड हो जाएगा, तो 7,4. So again we are tracking these integral points. I hope it is very very satisfying and very convincing, friends. मस्त लगा ना, मजा आया ये पढ़ के. So just tracking the integral coordinates on this line, yeah, and so on. ठीक है, I hope you understood. So this much you should know about linear equation, bare minimum. ठीक है.